Hi there, I'm Philip Walch, and I'm a resident of Applewood, and I'm here to talk to you about invisible waves that heal. In this talk, we're going to discuss X-ray, CT scans, and MRIs. These are technologies that many of us are familiar with. We've all had experience with one of these or the other. Now, the concept that ties all these technologies together is the concept of waves. We're familiar with waves from our living by the Jersey Shore. We see ocean waves go up and down, and the water comes into the shore. The up and down motion of the wave creates peaks and valleys, and we like to describe these peaks and valleys with something called a sine wave. Now, the sine wave, as you can see, is an idealized, very smooth wave, and sure enough, it has peaks and valleys, and it has a wavelength. The wavelength is the distance between a peak to the next peak over, and the height of the wave is called amplitude. The way we would describe a wave of low frequency is by showing a few waves, a few up and down motions in a time period, and a high frequency would be lots of up and down motions in the same time frame. Now, the technology that ties X-ray, CT scans, and MRIs together is electromagnetic waves, which are very familiar to us in our daily life. For example, you've all been using radios probably your entire life, and you know that radio waves are invisible, but they do create entertainment for us, news and so forth, weather. Microwaves, where would we be without microwaves in our cooking? Infrared is what you feel when you're near a hot oven. Also invisible waves, but you feel the heat. Visible waves we can see with our eyes. Ultraviolet waves give us sunburn. And of course, X-rays we're going to talk about in this presentation. Gamma rays are very high frequency and dangerous ways to stay away from. So moving on, we now start our quick discussion about X-rays. X-rays were discovered by this famous scientist here who was the first winner of the Nobel Prize in my field, which is physics. And he took a picture of his own wife, her hand, and you'll see that famous picture here. It's in all the books. And you'll notice that there's this wide object, dark object on her ring finger, which of course is her wedding ring. His equipment was very simple, but the principle is the same as what X-rays today use. You have a high voltage, you apply it to a metal cathode, which sends out electrons to a target, and when the electrons hit the target, they create X-rays which are able to escape this glass-walled tube. Here's a more modern picture of an X-ray. You notice the picture that's created gives you a very clear image of bones, but the skin and muscle are sort of cloudy white without much detail. The bones present more of an obstacle to the X-rays than do skin and muscle. Here's a picture of a poor person who has really a serious arm break, and you notice that the detail on the bones is very, very good. The detail of the knuckles and the wrist and so forth here. On the other hand, the muscle area is not very well defined. But this is a technology that has been in use for hundreds of years and is the fastest medical technology in history to be used by doctors. They took it up very shortly after Röntgen discovered the technology. A typical X-ray photon or light particle is about the size of an atom. And that is why X-rays are able to penetrate through our bodies and show the inside of our bodies. These are very high frequency waves. 10 to the 17th is 1 followed by 17 zeros. Here's this picture again. And you'll notice that the X-ray portion of the spectrum is up on the high end, high frequency, high energy. So these X-rays can be dangerous if we have an overdose. MRIs we'll talk about later in this talk. They're down in this region of the spectrum. Here's a picture of a typical atom. This is the hydrogen atom. There's 6 protons in the atom and 6 neutrons in the nucleus, and then 6 electrons on the outside. This is a neutral atom because there's 6 electrons and 6 protons, 6 positive charges balance 6 negative charges, and the neutron doesn't count because it's neutral. So this is a neutral atom, and you want most of the body's atoms to be neutral. Well, one of the things you should know about X-rays is that they're ionizing radiation, and you have to be a little cautious here. An X-ray photon will knock electrons off of some of the atoms in your body. It's inevitable. If it's not overdone, it's not dangerous. But what does it mean to create an ion? Well, this is a picture of a nitrogen atom, and one of its electrons has been knocked off. So now it's got 7 positive charges, 7 protons, and 6 electrons, and therefore it's a positive ion. When that ion wanders through your body, it can cause a little bit of damage, and too many ions like this can lead to things like cancer. When I was a kid growing up, my dad had an office attached to the house. He had an X-ray machine. My bedroom was up here over the office, so I actually lived and slept over an office that had an X-ray machine. Excuse me. An X-ray machine, modern X-ray machine, looks sort of like this. And you've all had X-rays, and you know what their equipment looks like coming down over your body. And here's a radiograph, which can be on a film or on a computer screen nowadays. Here's a doctor talking to a patient who eats too fast. And you notice that the result of eating too fast is he ate a few things he shouldn't have eaten. I thought this was a cute cartoon. Hope you like it. Here's a typical picture of a front view and a side view of an arm and an elbow. And you see the nice detail of the bone, different shades and different densities. The more dense the bone is, the more the color is white, and where the X-ray penetrates a little bit, it's a different shade of gray. And you notice here's a spot where looks like the X-ray went through completely. That's probably cartilage. Here's a picture of a mammography, normal breast versus a cancerous breast. Women routinely get mammograms, and they are very helpful in detecting the early stages of cancer, breast cancer. When I was a kid, I freely admit that I used to enjoy putting my feet right in here, wiggling my toes, and then looking at the wiggling toes with a fluoroscope. A fluoroscope is something that runs X-rays continuously, which means that we were continuously bathing our feet in X-rays, and that's no longer considered a safe procedure. But it was a lot of fun while it lasted. And here, you even had a certificate where you could do shoe fitting test data using this machine. Who knows how long you would do it and play with it and so on to fill out this form. Fortunately, these machines are no longer in use because of the danger of the exposure to radiation, needless exposure to radiation. Remember, X-rays are good for you because the benefit outweighs the risk. This is what doctors will tell you. But this was not beneficial enough to be worth the danger. Now here's a very important chart, and it talks about the dose rate allowed for X-rays. The rate for 1 year on this scale for whole body radiation from X-rays is 1 unit, called a millisievert. And you'll notice that dental x-rays are down here, and they are the lowest on the chart and very, very safe. Very, very weak radiation. When I go to the dentist now, I get an x-ray, and the next instant it's on a computer screen in front of me. On the other hand, if you have a whole body CT scan, now CT stands for computed tomography, and we're going to talk about that in a minute. You can see that that's over 10 times the yearly limit if you did it on your whole body. Luckily, most of us don't have to do that very often. But if it's necessary, it's worth the risk. And here's CT scan. Notice it's called CT scan, not CAT scan. Computed tomography scan is a way of displaying a cross-section on your body using x-rays and getting a three-dimensional view because the equipment rotates around your body as shown after this slide. This is what a CAT scan is, and that's not the right term anymore. Hope you enjoy the irony here. Here's a picture of an actual CT scan equipment working. The X-ray source rotates around your body, sending out a beam of X-rays, very, very low dose X-rays that scan through a whole portion of your body, many different beams, which are collected by very sophisticated electronic detectors and fed into a powerful modern computer, so that what you really have is a lot of data which no one could understand, which is converted into a picture by very clever software in the powerful computer. Marvelous technology. Here's another view of how the CT scan works. The motorized table moves forward, and the X-ray source also moves around you, as do the detectors, creating that image across one layer of your body here. And if you do this for several layers in a row, you can get quite a detailed picture, which is useful to the doctors. Here's an actual CT scanner, and you can see it's a significant piece of equipment. The rotating X-ray equipment, the computers, etc., and the detectors are all housed in here. Here's some beautiful pictures of a normal brain, and you'll notice very significantly that the skull is very solid white here, as you would expect for hard bone, but look at all the detail of the soft tissue inside the brain, very detailed pictures that you would never get with a flat image from a standard X-ray. This is CT scans again. These are, again, beautiful pictures from the CT scan. Of course, you would need a medical doctor to interpret the meaning of all these things. I'm not a medical doctor, I'm a physicist. And this is one of the proudest slides in my presentation here. Look at the color in this picture and look at the distinct 3D feel that you have to the picture. You really feel that this is not a flat image, but something showing the roundness of the head and so on. Wonderful. Finally, the last topic we're going to discuss today is the MRI. And the MRI is yet a different type of technology. I want to review once again the fact that atoms have a nucleus which has protons, and externally of the nucleus there's electrons. But the MRI uses the protons in the nucleus, which are charged particles, positively charged. Because the proton is positively charged and because it spins like a top, it acts like a tiny, tiny magnet, which can be flipped around and moved around in various sophisticated ways with both a fixed magnet, which is very big, powerful magnet, which is on all the time. They never turn this magnet off. and then a variable magnet, which is adjusted to make the proton spin around. And what happens is, as a result of this proton spinning and moving around, it gives off electromagnetic radiation of a very safe low frequency. Here's a real MRI. This is a closed MRI. Many of you have gone through the trouble of having an MRI in a machine like this. And this is an open MRI, which is used for certain people that can't do a closed MRI. The magnetic field of an MRI is enormous, the fixed magnetic field, that is, 10,000 times the Earth's magnetic field. Keep that number in mind as we move along. Notice that the radio frequency that comes from the MRI and makes the beautiful pictures of your body it is in a safe radio frequency range. It's not usually harmful to anybody. The reason for the enormous magnetic field is one simple reason: to get as clear a picture as possible. Here again, just to review quickly, the microwave is down here in this region of the spectrum, and the X-ray is up here. Here's some beautiful pictures of MRI pictures. Look at this one here, the vocal cords, the air passage, the tongue, all that detail, the nose, amazing detail. And definitely you get a three-dimensional view of the image. Now, there's some risks and problems with MRIs, as you can see from this chart. The strong magnetic field is something to be very cautious of. It's very irritating when you go into one of these machines and have to listen to the loud noises from the magnetic field, pounding, vibrations, and so forth. It's quite disconcerting, but it's worth the risk. Claustrophobia is a big problem. Some people can't do an MRI because they can't go into that closed volume for any period of time. Of course, before you do an MRI, they take all sorts of precautions to remove medical objects from your body. Radio frequency burns is on here, but I don't think it's much of a problem. Time and motion is another issue. This is a technology where you have to be as still as you possibly can in the equipment so as not to ruin the image. These are expensive procedures, and time is money. Here's a poor lady. The doctor is saying, "This is done. We'll slide you in there, scan your brain, and see if we can find out why you're having these spells of claustrophobia." Well, I have a pretty good idea without doing any of this, doctor, why she's claustrophobic. Now, this is an actual picture of a hospital bed that has some parts made of steel, and that powerful, powerful magnet caused the bed to come off the floor and stick to the MRI, probably damaging both the bed and the MRI. Told you it was a big magnetic field. Okay, what are the advantages at the end of the day to CT scans? Well, we can create an image of almost the entire body in a few seconds. They're useful for diagnosing and staging cancer, seeing whether it's come back, whether a treatment is working. You can survey the entire body, see if the cancer is metastasized, etc. The MRI is, in some respects, even better than a CT scan, and it pretty much says on this slide here that prostate cancer, uterine cancer, and liver cancers are hard to detect with CT, and sometimes metastases of cancer to the bone and brain also show up better on an MRI. Well, all of the technologies we've talked about today are used hundreds of thousands of times a day. They're wonderful, and they help us very much to better health. If you have any questions or comments on my talk, please don't hesitate to contact me. It was my pleasure to offer these thoughts and ideas to you, and I hope you've learned something. I've enjoyed making this talk, preparing it, and giving it, and I hope you continue to enjoy wonderful health and a happy life. And that's all, folks. Thank you.